This is a lesson on being able to apply adding and subtracting radical expressions and being able to collaborate in a small group on different types of problems that I give them on posters to be able to solve. And then we're going to have a gallery walk at the end to see who agreed to share work, give feedback, critique, which they should be critiquing as they're going around the posters, but we'll talk about it and do it in the discussion at the end also. After the gallery walk, we'll do what did they have difficulties with and what did they do well on. And so in the warm-up, I'm just trying to go over something that I think they may struggle with on poster 5, which is being able to find the side of a right triangle based using the Pythagorean theorem, because one of the expressions for the side has a radical in it, and being able to square that, since I haven't went over multiplying radicals this year yet until the next lesson, I'm going to go ahead and do that so they may be able to be more successful at that multi-step problem. And so then we had the legs squared, h squared plus 6 squared, because a squared plus b squared equals 6 square root of 2 squared. And I talk about, well, what does 6 square root of 2 squared mean? What does 5 squared mean? 5 squared means 5 times 5. So 6 square root of 2 squared means 6 square root of 2 times 6 square root of 2. Well, when you multiply radicals, you multiply the outside numbers, which is 36. You multiply the inside numbers, 2 times 2 is 4, and that's going to be equal to 36 plus h squared. And then square root of 4 is a perfect square, so when you evaluate that, that's actually 36 times 2 equals h squared plus 36. That's going to be h squared plus 36 equals 72. Subtract 36. And so h squared equals 36, and you take the square root of h, you get h is equal to 6, or the height of that triangle or altitude is equal to 6. And if some of the students expected them to remember 45, 45, 90 degree triangle when they saw the 6 square root of 2 on the hypotenuse, but I don't think any of the students did that. Maybe one in one class, but not in very many classes. And then on the second one, when you're plugging into Pythagorean theorem, you have 7 squared plus 5 square root of 3 squared equals c squared. And so again, you'd have 49 plus, when you multiply 5 square root of 3 times 5 square root of 3, you get 25 square root of 9 equals c squared. So 49 plus 25 times 3 is 75. Equals c squared. And sometimes the radical doesn't simplify. Sometimes it doesn't end up being a perfect square. And it just happens to in both of these cases. And so 75 plus 49 is 124 equals c squared. And I want them to leave their answers exact if it doesn't come out to a whole number. So if I take the square root of 124, that's going to break down into 4 will go into that 31 times, and that's actually a prime number. So square root of 4 would be 2 when it comes on the outside, and then the prime number 31 stays underneath. So the c is 2 square root of 31.